Operation Maintenance Diesel Electric Locomotive 55203. Operation Diesel Electric Locomotive Chapter 21. Other mechanical parts. 229. General procedures. Other mechanical parts required parts included non-electrical working, non-previously described manuals in the chapter running maintenance and diesel electrical locomotive repairs. Some items, auxiliary equipment such as traction mower, blower belt, feed, water pump, fuel pumps, various control switches, relays, protective devices should be removed for cleaning, calibration, adjustment, or replaced. And completely reconditioned units full of water. Steam lines should be cleaned, and all valves inspected to repair. Repairs and air through the compressor. Air through the compressor consist principally through the cleaning of the rigging, high-low pressure cylinders, renewal of the valves, including under valves and other needed corrections, renewal of defective parts of the bearings of the compressor crankshaft should be inspected, replaced if necessary, unless of the public braking trouble experienced with the crankshaft that will require little or no attention to the extended periods. Trucks should be removed and dismantled and completely. Trucks, frames, brakes, rigging, equalizers, mechanical parts should be inspected and cleaned. Equalizers should be tested for the magnetic tester. The pin bushing should be renewed, and if necessary, wear plates built upon replaced. And journal boxes should be dismantled and cleaned. Roller bearings should be checked and cleansed and renewed. Wheel and axle should be inspected, turned, and renewed if necessary. If the wheels are to be renewed, the axle should be tested the magnetic method after the uh, wheels are removed. The mounting and the axle bearings and caps should be given the necessary repair. Axle gears should be inspected. Brake cylinders should be cleaned and lubricated in accordance with standard practice. Slack adjusters should be checked. The complete air brakes equipment of the locomotive should be inspected and repaired. While mounting pressures referred in Table 4 must be used in pressure wheels on axles. Sanders will be checked before each trip to see if they have or operate properly. The stand control valve should be checked and cleaned annually, and as condition required, inspection cup, washer, oil ring, and composition rubber valve. Replace it if necessary. Inspecting sanding jets, making certain sanding jets are plunged, and examine the vent vapor. Examine the vent port, bottom of the actuating cylinder, making certain it is not plugged in. Check the spring, replacing the if leak, clean all the repairs thoroughly, and place a small amount of the air brake oil on the cup, washer, O-ring, or composition rubber valve before it is assembled. If the locomotive is equipped with a train heater, boiling system, or steam generator, it should be replaced with a reconditioned unit. Repaired with the next period of operation. Maintenance will consist of the removal of the coils of the cleaning, testing, and replacement of the necessary removal, reconditioning of the burner element, removal of the firebox section, cleaning the steam separator in the water treatment tank. The cab includes the safety appliance, water devices, windows, wipers, seats, or armresters, doors, and should be inspected and repaired. Table 4 shows a wheel mounting pressure in tons. Minimum and maximum pressure limits are absolute. No tolerance permitted. Class A through F. Journal sizes, wheel diameters, cast and iron, minimum and pressures, and steel wheels. 230. Packing and journal boxes. Generally, locomotive journal boxes may be packed with convenient waste as described and illustrated herein by using the AAR conditionally approved mechanical journal lubricating devices. The procedure applicable to the Department of Defense, railroad equipment named the federal stock number, the journal lubrication applicable to several journal sizes are contained in the DEA Technical Bulletin 552202525-1. New waste should be treated prior to the use of removal excess limit. New waste should be treated prior to the use remove excess in any form matter prior to the saturation. Waste journal boxes may be made all new, all renovated, or a mixture of new and renovated waste and oil. New waste should be mixed with old waste on a 50-50 basis prior to saturation. Practice prescribed herein are based on current AAR lubrication manual procedures cited in the above technical manual. Preparing for packaging. The waste must be loosened, therefore thoroughly placed in a saturating vat, kept completely submerged in the oil at a temperature of not less than 70 degrees Fahrenheit for a period of at least 48 hours to ensure proper saturation. Then it must be drained and remove the excess oil, leaving the packaging in resiliently and elastically condition. Oil should not drip from the drain packaging when lifted from the drain rack, and the oil should flow into when squeezed in the hand. Any process of saturation that will cause an equivalent result may be used. The packaging being currently used in vats and other containers must be turned over at least once every 5 hours. More frequently, if necessary, the oil which is accumulated in the bottom of the container must be drawn off of the poured out of the top of the packaging. Storing the packaging awaiting use must be kept in containers with tight-fitting lids to prevent contamination. See inspection of the journal boxes. Before packaging a journal box, the interior must be cleaned out of all dirt, sand, and scale grit from the box, as well as the inside of the lid must be wiped off. Remove the water if present. If the same treatment must be given in a new place, or replace boxes, including the dust guard wells and close-fitting dust guard plugs. Box lids complying with the specifications must be installed. Boxes must be inspected for the cracks, which might cause oil leaks. Journal boxes are described in paragraph 126. Application of packing. Applying sufficient packaging in one place of the B in all rolls A and C is shown in Figure 103 to firmly fill in space under the journal so as to prevent settling away. Taking care to having packaging bearing evenly along with the full length of the lower side of the journal. Free oil must be added to the box to do not contaminate sufficient oil after repackaging. Mechanical journal lubricators will be applied in accordance with the manufacturer instruction furnished in each lubricator shipping container. 2. The handling of removed packing. All reclaimable packaging removed from the journal must be placed in containers avoiding any possible contamination and shipped to the reclaiming plant. Such packaging must be not reused until it is renovated. Cleaning and installing bearings. Care must be taken thoroughly to clean all parts of the bearing and journal before installation and dry cleaning. Just zoom out of this. This shows a wheel journal or journal box. You have your cover, you have your wheel, your journals. Usually these are pin bearings that you pull out with a hook in reverse. Lining, and the journal box has the equalizer on the side of the frame of the dust guard keeper from the wheel. Solvent should be followed with a wipe down of the clean dry cloth when necessary to remove the metal from the bearing to obtain the proper fitting of the journal. To be sure that the proper tools do not use the sandpaper and memory cloth. Emery cloth of the abrasive particles will be embedded themselves into soft bearing metals, which will cause excessive wear. The bearing should be scraped, and always good practice to coat bearing surfaces with the prescribed lubricating oil. When installed is made wedge. The wedge must conform to the specific dimension. The wedge must be properly seated on the crown of the bearing so that it is not to pinch the side of the bearing or rest on the lugs. 231. The wheels and axles and repairs. Wheels and axles are inspected after each type of trip as part of the daily routine inspection. Wheels, which are also checked for wear, sharp flanges, shelling, cracks, and flat spots. Wheel set may be removed while the truck is under the locomotive. The truck itself may be removed and taken into a truck overhaul shop. Jack pads are provided on the body of the locomotive to support the locomotive frame when raising the truck. To remove the wheel axle without removing the truck, it is necessary to use a drop table. The end of the axles or bearing surfaces should be protected when journal boxes are removed. The service life of axles and gears will vary from the type of locomotive service, and because of the dangers resulting from the axles and cracks, axles should be given a magnolia or magnaflux test. Whenever the wheel is removed, magnolia is more effective than this. Inspection should be used each time a wheel is changed, regardless of the length of service. Danger of axle fatigue can be determined by a deposit of red metal dust on a wheel seat, including a wheel has worn loose or moisture has entered into the rust and rusted the metal. The crack indications of the axle of the transverse planes are dangerous, and the axle should be scraped. After the second pair of wheels is worn to its condemning limit, but the axle gears are free of the cracks and defection. The gears is not to condemn limits. New wheels may be applied. However, this practice is not recommended except when necessary. If the axles are not magnaflux to each wheel removal, the axle should be scraped after the two pairs of wheels have been worn to condemning limits. The axle gear is not magnaflux, should not be used beyond the life of two axles. When a pair of new axles is to be mounted on the axle The wheels must be carefully mated with a maximum variation of a 16th of an inch circumference or 0.02 of an inch in diameter. And if new wheels are available with these limits of variation, the old wheels are to be used. They should be matched and closely possible turn grounding after the mounting. The allowable pressure range for the wheel application for the using of the new and old wheels or axles is 70 tons low limit and 140 tons high limit. See Table 4, paragraph 229. A permanent record should be kept as the pressure recorded to the mount of the wheels. The wheels on the idler axles will require the same pressure as are used in the power axles. 232. The air compressor repairs. Disassembly, overhaul the air compressor periodically. Drain the oil in the compressor crankcase. Disconnect and remove the compressor coupling from the shaft to prevent damaging from the compressor bearings. Clean the exterior of the compressor thoroughly before the assembly. Mark the parts as necessary in order that they cannot be reassembled in the same so that they can be reassembled in the same relative position. When removing the crankshaft, the coupling device must be attached to the crankshaft end for the lifting, such as the device should be made by welding a stand or crankshaft nut to the U-shaped steel rod or strap to the form of a loop or sufficient size to permit the insertion of the hook and lifting the equipment. Lifting the shaft slowly and rocking the upper end of the shaft slightly if necessary, making certain that the lifting force is in the line with the crankshaft and otherwise bearing the damage might occur. Cylinder liners and pistons are removed and inspected to hone all cylinders. Retaining the surface after honing, checking the clearance between each position of the cylinder with the position rings removed. Also make certain that the cylinder flange face of the perpendicular cylinder bore. The crankshaft must be examined to see if it is bent or cracked or if the bearing seats are worn excessively. If such conditions exist, replace the shaft. C. Valves should be checked or lifted for lifter wear limit. Intercooler tubes should be cleaned inside and outside. Check closed whether any of the tubes must be replaced. Main bearings should be examined with the general condition of the proper clearance. The oil pump, the pressure lubrication system should be checked, and oil pump strainers should be screened, replaced. The compressor governor should be disassembled, cleaned, and oiled approximately once a year. Clean or replace the strainer element. 233. Aligning flexible coupling. General, if two or more rotating shafts are coupled, more alignment should be provided in order to eliminate vibration bending of the shaft. The method of securing satisfactory alignment will vary from the number of the bearings and on each shaft to the type of the coupling used. If each shaft with a single bearing is aligned properly, they will have no radial displacement, which are coupled at the ends. The angular displacement of the shaft at each of the shaft maybe has more than one bearing. A type of the coupling must be used which will permit a small amount of the angular radial displacement, since it is not always possible to achieve absolute alignment between the two shafts carried in the separate housing. B. Radial misalignment. Radial misalignment occurs when the center of the two shafts do not coincide with the displacement, causing excessive vibration wear of the coupling due to the radial movement of the two halves of the coupling will inspect each other. The displacement also causes the pulsating load on the bearings and thus shortens the life. The magnitude of the pulsating load will depend on the resistance of the coupling to the radial movement. C. The angular misalignment. Angular misalignment is present when the two shafts come together with a slight angle. In addition, with the setting of the vibration, angular misalignment causes the bending stress to be set in the shaft. Additional bearing loads more flexible on the couplings. This lessens will be loaded on the bearings and the stress set up on the misalignment shaft. 234. Locomotive test run. When the foregoing and the maintenance, attendance, and repairs are completed, also the electrical work is described in Chapter 22, the locomotive should be given this test run, making a final check of the operating adjustment conditions before it is entered in regular service. Although many operation conditions can be determined by the stationary loading test at the shop, the items may be running in the gear performance, braking, general bearing, heat, and other characteristics can be checked more effectively on an actual run. A test run should be verifying the traction motor's connection result in proper direction of rotation. The standing occurs during the emergency brake application. If so, provided the original design that circuits through the multiple units function properly. Chapter 22. Electrical equipment repairs.